So how many objects does a system have to be a complex system? We're going to look at this problem from the holistic thinking perspectives, and here's a reminder of what they are. You can look them up in the other presentations on my channel. So if we look at a system from the structural perspective, or perceive the system from the structural perspective, there are various definitions of complex and non-complex systems. And one of them that I pick out in particular is the one by Jackson and Keyes, which states complexity is in the eye of the beholder. From a functional perspective, complexity and complex systems are concerned when thinking about problems and issues. From the generic perspective, we see similarities in the definitions of complex and non-complex systems. They're the same. They have a common element of objects and relationships between the objects, as well as other aspects depending on who's writing the definition. From a continuum perspective, we note differences. There's a difference between subjective and objective complexity. Hilary Sillitoe pointed that out in his Incosi paper. And from the quantitative perspective, we note that some definitions of complex and complexity may contain numbers, but they're all different, and there's generally no justification for the numbers. So after thinking about the situation for a while, I came up with 3 questions, and I'm only going to look at one of them in this presentation. The others are covered elsewhere. So the question is, what is the value of large in the definition of objective complexity? Because systems engineers and operations research usually deal with specific numbers in requirements or in activities and whatever. And by not having defined the value of large in the definition of objective complexity, seems that they're all breaking their rules. So let's see if we can find a number. Sorry about that. So complexity and complex systems are an issue when thinking about systems. So what do we know about thinking? Well, here's a variation of the human information system model from psychology. I think it's cognitive psychology, where we have senses, seeing, hearing, smelling, tasting, feeling, and so on. That information goes into sensor memory. It's then extracted as needed into working memory, and after some processing, it's put into long-term memory, or even these days extended memory, which is outside the brain in the form of books and computer media. And that's what thinking about complex problems is all about, moving data around inside the brain from the different memories. So when we're thinking about the value of large, from the operational perspective, Jackson pointed out complexity is in the eye of the beholder. On the other hand, from the functional perspective, complexity is actually sensed by the eye of the beholder when the beholder thinks about complexity. So complexity is really in the mind of the beholder. Can we do anything with that? Well, from the quantitative perspective, we find Miller's rule. George Miller, again in psychology, stated out that the limitation on the number of management elements in the mind is 7 plus or minus 2. And as I speak this, the generic idea popped up that says, is that any way related to the number of fingers on 2 hands? But I'm not going anywhere with that at the moment. So my scientific out-of-the-box conclusion is that in all the definitions of complex systems, the value large should be replaced by more than 7 plus or minus 2, applying Miller's rule. Because what we're really doing is thinking about those systems. So let's take a look. Try and test the hypothesis. Is there anything out there, anyone out there, that is using that number to manage complexity successfully? And when you look at it, you find, yes, management of span of control. If you've learned anything about management, you've been taught about span of control. If you looked at organization structures in civilian, government, and military organizations, they all use the principle of hierarchies to reduce the elements that are being considered down to 7 plus or minus 2, or close enough to it. And even in engineering, Mayer and Rektin wrote, the way to deal with high levels of complexity is to abstract the system at as high a level as possible and then progressively reduce the level of abstraction. So, what is the value of large in the definition of a complex system? The answer is more than 7 plus or minus 2. It's time to close the loop and recognize that value. If you want further information on managing complexity, it can be found at your fingertips, as long as your fingertips are wrapped around my latest book, which came out in June and is available from CRC Press. And on my webpage, under publications, you can actually find a 20% off discount coupon. Thank you for watching this presentation.